All right, 8th grade math, welcome back. We are doing the 5th video of this Pythagoras packet. So yesterday, or whenever, you last left off with problem 2.3. And so this is the back of that next sheet. If you just go down to B, there should be a 2 and 3 at the top, and we're just going to pick up with B. We already kind of did 2 and 3 when we were labeling the boxes. Okay, so we have this diagonal drawn, and if you look back, you can find the area, but we could also just do it really quick. So this is a 2 by 2, and you're going to continue that 2 by 2 pattern. And this is how you draw your perfect box. And then this outer box is a 4 by 4. So that means the big red and green box has an area of 16. And then each of these triangles is a 2 by 2. That means each of these triangles is 2 times 2, which is 4, divided by 2, which is 2. The only time you divide by 2 is when you're finding the area of a triangle, so don't let that be tricky. So there's 4 2's, that's 8, which means what we have left over is 8 as our area. So since the area is 8, that means every single side length that results from dropping a triangle, making a 2 by 2, is going to be the square root of 8. So Ella says that this is 2 square roots of 2. I have none. Okay. I have none. Sorry. Okay, so Ella says that it's square root of 8, which we have, and then this next person says that it's 2 square roots of 2. Now, don't copy what I'm copying because we're going to find the side length in a minute, but if you remember the basic square, and you can flip back and look, this is 2 units squared, and you know that because you can break this up into 4 halves, which means the basic diagonal is a square root of 2. So a 1 by 1 triangle gives you a diagonal length of the square root of 2. So if you look at this, this is a 1 by 1 triangle right here, and this is also a 1 by 1 triangle right here. So it does appear that square root of 8 is the same as 2 square roots of 2. Now, you will be experts at solving square roots, but we haven't done this yet, so I'm just going to kind of give you a little appetizer. Think about all of your perfect squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, and so forth. So 4 goes into 8. So you could actually rewrite 8 as 2 times 4. I'm going to write that in the reverse order. Because the square root of 4 is 2, and the square root of 2 stays 2. So this is the same as this. That's true in the picture right here. That's true if we did another one to make this 2 square roots of 2 is equal to square root of 8, and it's true doing the math. So I want you to pause right now, in a minute actually, after you listen to me, and see if you can figure out what this dimension is. So go ahead and hit pause, see if you can sort of kind of draw a square off of it. Okay, so maybe you didn't have to draw the whole square. Maybe you could just sort of draw, knowing that this is a 2, and this is 6. And if you continue a 2 by 6 to get the triangle to give you the square, then you would continue a 2 by 6 Whoa, okay, just pretend that's straight. All right, so the outer box here is 2 and 6. And the outer box here is 2 and 6. So the outer box, even though this is definitely not a perfect drawing, is 8 by 8, which is 64. Each triangle is 2 by 6. There's 4 of them. And 6 times 2 is 12. And since it's a triangle, you need to divide by 2, which is 6. So 4 sixes is 24. So you're left over with 40. This square's area is 40. So every diagonal length is square root of 40. And then it says, see if you can express that in 2 ways. So the square root of 40 is the same as 4 times 10. So you could express that as 2 root 10. What I actually want you to do is do this again. See how it stopped in the middle here? So we're going to look at this as a 1 by 3. See how it's 2 1 by 3s? So on the side, actually down here, draw a triangle. If you have colors, use colors. And make it a 1 by 3. Once you have that, what you should know is that when you draw your perfect square, your box on the outside is always going to be the 3 and the 1 added. So it's going to be a 4 by 4, which is 16. And then each of the triangles, there's going to be 4 of them, and this is a 3 by 1, so each triangle in this case is 1 1/2, and 4 1 1/2 is 6. So that means this square's area is 10, so every side length is the square root of 10. So we've just written this 2 different ways. One is the square root of 40, the other is 2 square roots of 10. And this chunk is the same as this chunk, so it does appear to be 2 square roots of 10. So are there segments that cannot be broken up? Well, that would be any segment that doesn't have a perfect square root coming out of it. If you flip back, actually let's just do another one. How about a 1 by 4? See if you can, without necessarily even drawing the whole square off of it, see if you can figure out what that diagonal length would be. Just doing kind of what we did right here. So go ahead and hit pause, see if you can get that diagonal length. Okay, so if you drew this square, this 4 by 1, the outer box would be a 5 by 5, which is 25. Each triangle is a 4 by 1. There's 4 of them. There's always 4 of them. So 4 by 1 is 2. 4 2s, 2, 4, 6, 8, is 8. So 25 minus 8 is 17. So the side length is the square root of 17. If you think of all of the factors of 17, 17 is a prime number, so the only factors of 17 are 1 and 17. There's no way, if you have a 1 by anything, to break it up into 2 smaller triangles. The one above here, you had to break that up 1 by 3, 1 by 3. That's because it was 2. You can't do that when the dimension is 1. And there's a bunch you can't do. Any odd number, you can't break it up evenly. So there are many in number 2. So if you flip your page over now, we are in 2.4. And we're going to talk about volume. So far we've been talking about area. Volume is 3-dimensional. That's length times width times height. So 1 times 1 times 1 is 1. 2 times 2 times 2, 2 cubed is 8. 3 times 3 times 3, 3 cubed is 27. 4 times 4 times 4 is 64. And 5 times 5 times 5 is 125. So these numbers that I just wrote are all perfect cube roots. So this would be a cube. That's a 1 by 1 by 1. This would be a cube. That's a 3 by 3 by 3. This would be a cube. That's a 4 by 4 by 4. And this would be a cube. That's a 5 by 5 by 5. Now, if you are looking at something like this, there's no number right here. See how there's all of a sudden numbers right here? This, if there's no number right here, is meant to be a square root. And so the square root of 8 we don't know, but the square root of 9 we know is 3, the number squared that gives you 3. So the cube root is just what number cubed gives you that. So the cube root of 1 is 1, because 1 times 1 times 1 is 1. The cube root of 27 is 3, because 3 times 3 times 3 is 27. The cube root of 64 is 4, and the cube root of 125 is 5. Next, it says, what is the volume of a cube with an edge length of 5 units? So, if every single side length had 5, you would do 5 times 5 times 5, and you would get 125 units cubed, because it's 3-dimensional now. Area is always units squared. Volume is always units cubed. Next, it's the same question with an edge length of 2.5. So 2.5 times 2.5 times 2.5. There is actually on your calculator, there's a y to the x button, or if you have the graphing calculator, there's a caret button right above the division sign, and that's an exponent. So you could, on your calculator, do 2.5 to the third. I think I could actually bring it up right here. Yeah, so you can bring your calculator up that you've downloaded, and so 2.5 to the third. See that? So that's 15.625. Okay, so in number 2, it says the cube root of what is 5. So that'd be the cube root of 125, because 5 times 5 times 5 is 125. And then in letter B, it says the cube root of what is 2.5, and that'd be the 15.625, because 2.5 times 2.5 times 2.5 is 15.625. So now we're going to solve for x. So basically, you need to know what number times itself again gives you 27. So you're going to kind of take the cube root of both of these. So x is going to be 3, because 3 times 3 is 9, times 3 is 27. If you take the cube root of this is kind of interesting because it says negative. In square roots, the square root of a negative is impossible, but negative 3 times negative 3 is negative 27. So in cube roots, you can do negatives. Any odd root you can do in negative. So the cube root of 1 is just 1, and the cube root of 8 is 2. So it's 1/2. Okay, so now you have the cube root of what number gives you 27, and that would also be, this is different. So up here, it's what number cubed gives you 27. So now it's what do you put in there to get 27 when you take the cube root. So you'd have to go back to your calculator and do 27 cubed. And you'll get 19683. So that's what x is equal to. So that's saying that if in the calculator, if you put the cube root of 19683, you'll get 27. I'll show you how to do that in the calculator. Pull your calculator back up. So the cube root is under math. And if you look at number 4, that's the cube root. So the cube root of 1, see how that's our last answer? So you can actually put second negative and it puts the last answer in, 19683. Or you could type in 19683 and you get 27. Okay, the next question's the same exact thing. This time it's a negative 27, so it's actually negative 19683, because negative 27 times negative 27 times negative 27 will be negative 19683. Okay, so this one, so I need to figure out what negative 1/8 times negative 1/8 times negative 1/8 is. Or I should say you need to figure that out. So basically I'm just going to do 8 cubed, and I'm not forgetting that it's negative, and it's 512. So the cube root of negative 1 over 512, remember if there's one negative, the whole fraction's negative. Negative 1 over 512 is the same as 1 over negative 512. That's the same as negative 1 over 512. So all those are the same. So the cube root of negative 1 over 512 is negative 1/8. So the answer is x equals negative 1 over 512. So now it says, between which two whole numbers does the cube root of 10 lie? So we know that 1 cubed is 1, so the cube root of 1 is 1. And 2 cubed is 8, so the cube root of 8 is 2. And 3 cubed is 27, so the cube root of 27 is 3. And 4 cubed is 64, so the cube root of 64 is 4. And 5 cubed is 125, so the cube root of 125 is 5. So this says the cube root of 10. That would be right here. So it's between 2 and 3. Closer to 2. So let's guess, this is probably going to have us do this. Which whole number is closer? So 2, I'm just going to keep pointing to what I did. Without using a calculator, let's guess what it is. I'm going to guess it's 2.23. Total wild guess, closer to 2. Might even be 2.1 because it's quite a bit closer to 2. So we're going to actually do this in the calculator. Cube root of 10. So bring up your device, and cube root was under math, number 4. And if you see under number 4 there's number 5, that's the x root. You could do any root. You could do the 4th root of something. That's just that number times itself, so that there's 4 of those numbers. So the cube root of 10 is 2.154. So it is more like 2.1. You could draw a square on centimeter grid paper and measure it with a ruler. you could guesstimate and you could use a calculator. So probably this person used a calculator. This person probably used a ruler on dot paper. And the other person might have just guessed using what they know about square roots. Educated guess. With a cube root. I think I just said square root rules. Okay, so which is greater, square root of 8 or cube root of 8? So what is the square root of 8? Let's think of our squares. Square root of 1 is 1. Another perfect square is 4. Square root of 4 is 2. Another perfect square is 9. Square root of 9 is 3. So the square root of 8 is 2.8-ish. And the cube root of 8, 1 cubed is 1, so the cube root of 1 is 1. 2 cubed is 8, so cube root of 8 is 2. So the square root of 8 is bigger. The square root of everything is bigger because a number times itself versus a number times itself, to give you the same number, is going to have to be bigger, if that made any sort of sense. Okay, we're calling it a day. Have a lovely evening.